Juno's closest flyby of Io. Hubble studies an exoplanet atmosphere for 3 years. Astronauts test out Starship's elevator, and more evidence for quark stars. All this and more in this week's Space Bites. So NASA's Juno spacecraft has been exploring the Jovian planet and its moons, and just completed its 57th flyby of Jupiter. Now, the way Juno works is that it does these big, long, elliptical orbits around Jupiter. It gets close, takes a bunch of pictures, gathers some data, and then it flies back out, safe from all of the radiation in the inner region. And then it makes another flyby, gathers a bunch of data. And this approach is now being considered, it's going to be used for the Europa Clipper. You can see it's a great way to be able to have a spacecraft be in a fairly dangerous environment and still to be able to do a bunch of science. And so now that Juno has completed kind of its main science objectives in studying Jupiter, NASA's just sending it out in other places in the system. And so it's been making a bunch of flybys of Io, which is the closest moon into Jupiter. It's also the most dangerous one. It's the one that is closest in to Jupiter's extensive magnetosphere. And so more damage is probably going to happen to Juno as it makes these flybys. Now, it's already done a bunch of flybys, but on December 30th, 2023, last year, it did a flyby that brought it within 1,500 kilometers of the surface of Io. And that sounds close, and it is for Juno, but in fact, NASA's Galileo spacecraft made an even closer flyby about 20 years ago. And so Juno is still catching up to the work that Galileo did. And every time we get close-up flybys from Juno, then all of the citizen scientists take those pictures, produce much cooler versions of it. And so here's a bunch to look at, one from Kevin Gill, who is one of my favorite image processors. Now, Juno has another flyby planned on February 3rd. It's going to come to about the same distance. Of course, planetary scientists have a lot of questions about Io. And if you want to learn what some of those questions are, I did a really amazing interview with Dr. Ashley Davis from NASA JPL. He has been studying these images coming back from Juno and has a lot of really interesting theories about what's going on, what's driving all of this volcanism on Io. Hubble studies an exoplanet atmosphere for 3 years. We're in the golden age of studying exoplanet atmospheres thanks to James Webb. We've got just this exquisite data on many different exoplanets. We're seeing the presence of carbon dioxide and sulfur dioxide and methane and water vapor and all this kind of stuff. But that's not the first instrument that was able to analyze exoplanetary atmospheres. The first tentative work was done with other infrared observatories, like Spitzer, and Hubble is equipped with the instruments that will allow it to study exoplanetary atmospheres. And so back in 2016, astronomers tasked Hubble to observe the atmosphere of a very famous hot Jupiter planet called WASP 121b. It's located about 800 light years from Earth, and it completes an orbit around its star every 30 hours. So that's very close. It is a very hot planet. And so astronomers used Hubble to observe various phases of this orbit of the planet going around the star. They're able to see as it passed directly in front of the star, and they're also able to observe when it passed behind the star. And you also get when it returns from behind the star. And so you get these multiple observations. Astronomers were able to observe back in 2016 and detect the presence of the atmosphere. And then they came back and did some more observations in 2018. And then they came back and did more observations in 2019. What they've done is then put together all of these data from those 3 separate years of observation. And they found that the atmosphere is changing. And when they made sophisticated models of the atmosphere of WASP 121b, what it seems to be is that there is some kind of giant cyclonic storm on the surface of this planet that is shifting its position and causing the different readings that they were detecting with each one of their observations. And so this is like the next phase. I mean, we've gone from finding exoplanets to detecting the atmospheres of exoplanets, and now we're moving into detecting the weather in the atmosphere on exoplanets. Now, once again, I've done an amazing interview kind of all about this concept of what it takes to observe the atmospheres of exoplanets. So check that out. An ancient stone with an accurate sky map. So archaeologists were studying an ancient fort that had been found in Italy, and they were unearthing various artifacts in this region. And they found these two stone discs that were like clearly man-made. And on the discs, there were 29 spots that had been chiseled in. And astronomers looked at those spots and they were able to match them up to the stars in the sky. They were able to see a lot of very famous, very bright stars. They were able to find the stars in the belt of Orion. So based on the positions of the stars, they were able to then calculate when these stone discs were made, because of course all of the stars in the sky are moving slowly. And so if you chart the positions of the sky at any point in history, you know when you were looking at those stars. And so they dated these star positions to between 1800 BCE and 400 BCE. But one really interesting mystery about this is that in fact there were 29 spots chiseled on the discs, while they were only able to match up 28 stars. And so what they're thinking is that additional mark could be connected to maybe a supernova that appeared in the sky. And so maybe that was the reason why they made these discs, was to chart the appearance of a supernova in the sky. So it's a really cool mystery, and it shows you how ancient texts can be used for astronomy to understand more about what happened in the past in the sky. More solar flares are coming. So as you probably know, we are moving towards the peak of the solar activity. It's called solar maximum, and we're still probably about 18 months away. And already this is shaping up to be one of the most active solar cycles that we've ever seen. Like if you compare this year's solar activity to last year's solar activity, it's already much more active. And a couple of days ago, the sun released its most powerful solar flare in 6 years. It was an X-class flare, X5, which is very powerful. And the last most powerful flare happened back in 2017 when it released an X8.2 flare. The results of the flare hit the Earth just a couple of days ago. And so if you happen to have clear skies and you live in the northern latitudes, southern latitudes, you'll be able to see the northern lights. Now, this is an amazing time to see an aurora. If you've never seen an aurora, this is your chance. And so I want to talk a bit more about how you can maximize your chance of seeing an aurora during this solar cycle. We'll talk about that at the end of the show. NIAC 2024 is out. Now, of course, this is a big moment for us here on the channel, and that is that NASA has released the 2024 awardees for their advanced innovative concepts. This is where they give tens of thousands of dollars to about a dozen groups who are coming up with out-of-the-box ideas for space exploration. And it just came out today, so I'm still kind of digesting it. But of course, we're going to do a full court press. We're going to cover all of the interesting ideas. I'm going to try to interview as many people as possible. We're going to release a video where we give you more information about it, so stay tuned for that. Every week, we do a vote on our channel where we ask you to tell us what you thought was the best space news story of the week. And 2 weeks ago, the top vote was the possibility of black holes inside stars, which just slightly beat out the cat video Tight Beam from Space. And like, I get it, it's cool. I disagree, but thank you everybody for voting. Now, we will post the vote shortly after we release this video. And so if you want, you can go to the community tab, give your vote, or just as you're scrolling on YouTube, you should see the vote show up. Give us a quick vote. Help us know what you thought was the best story. Of course, the best chance to see that vote is to subscribe to the channel, click on the notification bell. That should give you a much greater chance of seeing the vote. Ouch, Canadarm2 hit by a meteor. Every now and then, astronauts are reminded that when they're out in space, it is not a completely calm place, that in fact there are untold millions of tiny pieces of space debris moving at tens of thousands of kilometers per hour, buzzing around them at all times. And we got a really great example of this with a new photograph that was taken by ESA astronaut Andreas Mogensen. He took a picture of the Canadarm2 and showed this chunk that was taken out of it by a micrometeoroid or a piece of space debris. According to Mogensen, the impact happened back in 2021, and it was from a 1 millimeter object traveling at 25,000 kilometers per hour that struck the Canadarm. It went through the insulation covering the arm and actually struck the arm itself. It didn't cause any problems to the operation of the Canadarm itself. It's just this reminder. Now, we've seen examples where it actually has caused damage and it was a problem, like with a hit on the NUCA science module, caused a coolant leak. There have been hits on the solar panels. So just like this reminder that when you go to space, it's still pretty dangerous. Starship's moon elevator tested. NASA chose SpaceX's Starship as the lander for the upcoming Artemis 3 mission. And the choice seems kind of strange because Starship is gigantic. It is 50 meters tall. It is 9 meters across. And so when the astronauts arrive at the moon in their relatively tiny Orion module, they're going to transfer over into a Starship that's designed to land on the moon. And then they're going to go down to the surface of the moon. And then they're going to be over 40 meters away from the surface of the moon. And even in the low gravity of the moon, it is not safe to jump out of Starship. They're going to need some way to get down to the surface of the moon. And the plan is an elevator. And so we got some cool images of NASA astronauts in their spacesuits testing out this elevator to find out how it's going to work to be able to get them from the crew compartment on Starship down to the surface of the moon and then back up again. Well, we did it. We completed 2023 and we produced an enormous amount of space content for you. So here's some interesting stats. We did 51 episodes of Space Bites. We missed one episode because of the Christmas to New Year's holiday, and there just isn't a lot of space news. We released 37 episodes of the QA. We answered 442 questions, plus a whole bunch of overtime questions and Patreon exclusive questions. We published 1,371 stories on Universe Today. I wrote 52 newsletters. Didn't miss a week for the entire year. We did 71 interviews with a total of 57 hours, 1 minute and 34 seconds. And all of that content is available on the website, in our podcast, as well as additional interviews with me on the podcast feed. And everything we do is done with a minimum amount of advertising. And the only way we can do that is thanks to the support of the patrons. And so with more patrons, more content, less ads. We are producing an enormous amount of space content. We've got a very large team. And if you want to help support what we do, have an independent space news group, go to patreon.com/universe today and support the work we do. More evidence for quark stars. Neutron stars are what you get when a star that is much more massive than the sun explodes as a supernova, and then you get this collapsing, infalling material that, and I believe the technical term is smushes the protons and the electrons together to form neutrons. And so you have this ball of neutrons. It is a neutron star. Now, normally individual neutrons, if you just have like a neutron hanging out, it's going to decay within a few minutes. But because of this intense gravity that's holding the neutron star together, they don't decay. The quarks are bound too tightly to be able to escape. But one theory is that for the most massive neutron stars, the quarks do escape and they sort of percolate down to the center of the neutron star and they form this ball of quarks. And this is like the last stage right on the edge where if it had any more mass, it would turn into a black hole. So researchers have done a bunch of observations of neutron stars and have done fairly detailed simulations, and they're predicting that the heaviest neutron stars are like 80 to 90% likely to have an inner core that is made of this quark material. And so with more observations, we should find more evidence. And it might very well be that there are stars that are right at the edge between neutron star and black hole that are made with an enormous amount of quarks. It's like a super exotic form of matter before you get a black hole. Finally, we've got a couple of really cool images for you to look at. The first is called the Running Chicken Nebula. I don't see it, but maybe you do. Now, this image was taken by the European Southern Observatory's Very Large Telescope, which is one of the largest telescopes in the world. The region is gigantic. It's about 25 times the size of the full moon. And so in order to be able to image the full complex, they had to take a ton of separate images and then stitch them all together into this gigantic mosaic. And so the underlying image is monstrous. It is 1.5 billion pixels. And the final image, if you want to download the full resolution, it's a 1.5 gigabit image. Like, who has a monitor that is that big? I don't know. Now, in this image, you're seeing all kinds of things that you would see in a star-forming region. You're seeing clouds of nebulosity. You're seeing emission nebula. You're seeing reflection nebula. And you're seeing Bok globules, which are regions of like dark gas and dust that resist the radiation that's coming from all these newly forming stars. So it's a beautiful image. And that full resolution, you could just be looking around from area to area for hours. But again, warning, it's gigantic. And finally, an image of a star-forming region called 30 Doradus b, which is located in the Large Magellanic Cloud. So it's about 160,000 light years away, but it is part of this larger complex. It is like the largest star-forming region in our vicinity. And some of the most massive stars that have ever been found are in this star-forming region. It's believed to be about 8 to 10 million years old, which means that it's still fairly young, and a lot of the most massive stars, the ones that die within just a couple of million years, they've already died, detonated as supernova, polluted the region with heavier elements that will then go on to form the next generations of stars. And so in this image, there's actually multiple supernova remnants that were detected through a combination of the Chandra X-ray Observatory and the Hubble Space Telescope. And so it's really cool to see like a star-forming region that is also filled with supernova remnants. Very cool. Now I'm going to talk some more about how to maximize your chances of seeing an aurora, but first I'd like to thank our patrons. Thanks to Hey Twyla, Dougie Stewart, Stephen Krasaki, David Richards, Mark Anstis, Joel Yancey, Antonio Lofilara, Dustin Cable, Vlad Shiplin, Modso, George, David Giltonet, Andrew M. Gross, Jeremy Mattern, Josh Schultz, Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So for some of you, you have seen a bright aurora, and you know exactly what I'm talking about. And for the rest of you, you've never seen this, and you should. So when you get this heightened solar activity, you get these coronal mass ejections, these flares that are coming off the sun, they're interacting with the Earth's magnetosphere, and you get these auroras in the sky. And during the heightened solar activity, they can happen every couple of days sometimes. And the strength of the storms create much stronger aurora activity. And now astronomers have gotten very good at predicting when and where the flare activity on the sun is going to turn into auroras here on Earth. And so normally you want to be really close to the poles. You want to be living in Iceland or Alaska or Antarctica to be able to see the auroras. But under these larger storms, you can get aurora activity that is shifting really far away from the poles. So for example, you could see auroras in the middle of Europe. You could see it in the middle of the US. You could see it in southern Australia. Much higher chance. But you have to be organized. And so you have to get some kind of aurora alert app on your phone or follow the NOAA's aurora alerts. I don't have an aurora alert recommendation, but there's plenty on various app stores. And then when you get an alert of a really intense geomagnetic storm, you got to see if there's going to be some aurora activity in your area. And then you have to go to a place that is dark, away from city lights, that gives you a view towards your closest pole. And then bring a camera, do some long exposure photography. But if you're lucky, you won't need any of that the sky will erupt with green glows and flares and flickering curtains of, it's amazing. It's amazing. And when you see it, you just can't get out of your head and you want to see it some more. I'm going to share some aurora time lapses that I took, that I saw, and like, it just doesn't compare to what I actually saw. But this should give you an idea of just like what I saw here at my home in southern Canada. And of course, if you really want to get a chance to see it, book a trip to a place like Alaska or Iceland or Antarctica, and you should get a shot at being able to see an aurora. All right, we'll see you next week.